Okay, so I'm going to talk for a little bit about sets. This should all be review. If this is not review for you, then you should be going through it like crazy or going back into discrete math or discrete structures. Okay, so here's an example of a very simple set. It has 4 elements. They are A, B, C, and D. And I like to think of a set as just a bag that has some elements in it. So in this case, here's a bag with A, B, C, and D floating around in it somewhere. Now, since the letters are in this bag, it doesn't really matter what order. We could kind of shake the bag a bit and the letters could change order. That means that this set that I have here is actually exactly the same as the set containing A, C, D, and B. And that's the same as the set containing C, A, B, and D, right? Order does not matter in a set. The other thing that it depends on who you're talking to and the book that you're using, but for the purposes of our class, if you list an item twice in a set, it doesn't really matter. So if we put A in there a couple of times, doesn't matter, each item only really appears once, so that means that this set is actually the same as these ones and is just represented by this bag full of stuff. So if we want to talk about the union of two sets, that's really taking all of the elements that are in this first set and putting it together with all of the elements in this second set. So here we've got two sets. Our first set, A, B, C, D, 4 elements. A, B, C, and D are in our bag. We want to union that with the set that contains C, D, E, and F. So let's just put C, D, E, and F floating around in here. In this particular example, both sets have 4 elements in it, but it doesn't really matter. So if we are taking the union of these two sets, right, so if we're taking the union of this first set and the second set, that just means we make a new bag that has everything that is in both the first set and the second set. So let's just shrink this down a little bit so we have a little bit more room. And let's see, so in the first bag we have A, B, C, and D, and we can float them around wherever we want. In the second bag we have C. I can write it again if I want. I'm only going to copy it out once later. We have D, we have E, and F. So the union of my two sets is going to be everything that is in this bag, which turns out to be A, B, C, D, E, and F. Right? Similarly, we can take the intersection of two sets. So if we want to take the intersection of these two sets, that means finding all of the items that are in both of the sets. And so let's take a look. In here we have an A, no A in there, so that's not in the intersection. And we have a B, but no B in here. We have a C, and sure enough, we have a C in there. So we need that to add that to our intersection. So there's a new bag, and we'll put that C in there. And we can look again. The last item in here is a D, and there's a D in there. So sure enough, we can put a D in our bag. So the intersection of these two sets is just the set CD. And hopefully that was all pretty trivial for you. Things get more complicated when we start talking about more interesting sets. So for example, we can talk about the empty set, right? And the empty set is just a set with nothing in it, right? So, that's a way to represent the empty set. That's a way to represent the empty set. And here's a way, if I'm drawing pictures, I can represent it. It's just an empty bag. So now let's look at this more complex set, or we have two more complex sets here, okay? So the first one, let's just count how many items are in this set, right? In this set we have one item, the letter A, or the symbol A. This set is a second item. Letter D is a third item. E, F, G altogether is a fourth. Empty set is a fifth. That set of two things is the sixth, and that I is the seventh. So let's just take our bag, and maybe I'll make it a little bit bigger so we have some room to put stuff in. We'll ignore that thing on the bottom for a minute. We'll deal with that set on the bottom in a second. And let's just see what we've got in here. So in here, in our set, the first thing we have is the symbol A, so we can just write that in here. The second thing we have is a set that contains two symbols B and C. So what we need to do is we need to put a new bag in our bag, right? So there's a little bag in our bag, and that bag has a B and a C floating around in it. Next we've got the symbol D, that's just floating around in our big bag, so we can put that there. Next we have another bag, right? This is a bag that has, another bag in it. So we've got E, F, and G. So we have E, the set containing F, and G. So let's just deal with this set, and then we'll stick it into the bigger one. So in this set, we have an E, a G, and another set containing F. Let's make this, make this a little bit bigger, and we can put inside there, we've got E, we've got G, and then we have another set inside of there. And inside of that other set, we have this F. So we'll stick that in there. So now we need to take all of the stuff in this bag, right? This whole set is part of this big set that we're trying to figure out. So what I'm going to do is I'm going to take this bag, I'm going to shrink it down a little bit, right? The size of a letter in the bag doesn't really matter. And that's in there. Next up, it looks like we have the empty set in our bag. Well, the empty set is just an empty bag, right? So we'll take that and we'll throw that somewhere. And next up we have, well, look at this. We've got a set that has two items in it. So let me start with a new bag. So there's my bag for my set. It has two items in it. The first item is actually the empty set. So we'll stick an empty little bag in there. And the second item in this little set here is the letter H. So we'll put an H in there somewhere. And now I can take this whole bag and put it in there. And finally, if we look at our set, there's the letter I that's just kind of floating around in there. So there's the I. So this whole big bag here, which has some bags inside of it, and some of those bags have another bag inside of them. Sometimes it's an empty bag. That whole thing represents this complex set here. So I'm just going to take that and put that up there so we can kind of remember it for this first one. Okay. And now let's just take a look at the second set that I have right here, and let's do the same thing for that. So of course we have to start with the big bag. Let's see, what if I put it there for now, and we'll shrink it down later. And in there we can see first it has three elements, an A, a B, and a C. So we'll put A, B, and C in there. Then inside we've got another set that is D, E, F. So let's get another bag, and into that bag we're going to put D, E, and F just floating around. And of course this, this bag here is going to go into there. Right, very good. We also need to have the empty set in there. So let me stick another bag that's the empty set in there. And we need a bag that has the empty set in it, right? And remember that this piece here could also be written like this. It's the set with a set inside it that has nothing, right? It's just that we find that this notation for the empty set makes things a little bit easier. Okay, so back to where we were, we need a bag, and inside of that bag we have to have another bag so that we represent a bag that has an empty bag in it. So there's that. And now we can take this thing and squidge it down so it will fit and put it in there. And it looks like the rest of what we've got in there is pretty simple, just three symbols, G, H, and I. So G, H, and I. Okay? So let's just grab this and shrink it down. And you can see, I don't want to overwrite anything. There you go. It's about as big as I can make it. So this set here is represented by that bag there. So let's take those two sets that we have and figure out what the union of them is, right? So I want to know what that is unioned with that one. And I wish I could draw you the bags here, but it's awfully hard to do that in the software, to copy and paste all that stuff. So I'm just going to do it by hand. So the union of these two sets is really the set that contains everything in this one and everything in this one. So that's not too bad. If we start with this top set, we have an A, we have the set BC, D, and then we have an E, F, G, right? I'm just copying it. I'm going to continue on the next line because I don't have much room. Empty set, the set containing the empty set, and also H and I. And then we just need to look at this one and see, what are we missing? Well, let's see. We have an A. We don't have a B by itself, right? Because if you look, this first one is a B that's already in a bag, right? Rewind the video if you don't remember that. But this one is a B and C that's in an inner bag inside of this outer one. So we need to add a B. We also need to add a C. Looks like we need to add that D, E, F too. All right, hang on. So let's just shrink that whole thing a bit so we have some more room. And so we got up to the B. We also have a C in here. So let's stick that in. It's going to be a little bit bigger. You'll just have to deal. And then there's the set containing D, E, F. We didn't have that up there, so we need to add that as well. All right, what's next? The empty set. Oh, well, we had the empty set already, right? There it is. So we could write it again, but no point. So let's just keep going. We have the set containing the empty set. We didn't have that before. So we'll add that. And of course, remember, instead of writing this set containing the empty set, we could have also written the set that, not beautiful, but the set containing the empty set, right? But we'll leave that out for now. So we have the set containing the empty set, there it is. And then we have G, H, and I. Well, G and H are nowhere to be found here, right? They're not in here. I mean, there's a G, but that's in another bag, and there's an H, but that's in another bag. But I is here already. We see it right there. So I just need to add my G, my H, and my close curly, and that's my whole set. Now, if I'm trying to take the intersection of two sets, that's an entirely different problem, right? Now I need to find all of the items that are in here that are also in here, and there's not very many, I don't think. So let's take a look. The intersection of these two sets. Well, I see that A is also in here, so I can write an A. If I look, I don't see a set containing BC down here, so I'll skip that. Is there a D by itself? Nope. A set containing this stuff? Nope. The empty set by itself? Oh yeah, that's there, so we need to add that down below. Just to show you, I mean what I say, we could write that like that here, right? Of course, we could also have written just the empty set in there, but they're both the same thing. This first one here is just a way we represent that in shorthand, because this is hard to draw. But that's fine. We'll do it this way for this time. So we have the empty set where we're here, right? Do we have a set containing the empty set in H in here? No, we don't, but we do have the singleton I. So we will add that, and we've taken the intersection.